All right, so we are dealing with double angle and half angle formulas today. Oh, something I did, I want to make sure you realize all three of these are cosine 2u. Okay, you can use any of these you want. This one here is probably my favorite to use right there, but I use all three of them depending on the situation. Down here's the half angles. There's two different half angles for this. I use this one the most. Whenever I got a choice, I'm going to use that one. And the reason I'm going to use that one is the denominator is only going to have one term. The denominator will have one term, and that makes it easier to simplify. So if I get a choice, I'm using this one. Okay? So we're going to do these problems you guys pick. We're going to do number 3, which says expand each expression. We want the cosine of 2b. So which angle type is it when it's got a 2 in front of it? That's a double angle. So if there's a 2 in front, that's double angle. So we're going to use these up here. And this says, if I'm not mistaken, it was cosine of 2b. So how many different answers, looking back over here, since we're doing cosine, how many different answers could you have for this problem? 3 different answers, and they would all mean the same. Now, what's the difference between the problem that we just looked at on the other page and this and those problems up there?
On the other one, you have to plug in.
You got a what? What are they plugging in on the other one? On the one on the homework problem. What? Over here, what are we plugging in? What does u equal over here? B. So in other words, on every one of these problems, wherever there's a u over here, all you do is put in a b. And you're done. Because we're taking from this condensed version and expanding it into these. So you pick any one of these you want, and you would be fine. So you could say this could equal cosine squared b minus sine squared b. You'd be fine. You could say this equals 2 cosine squared b minus 1, and you would have been fine. You don't need all three of them. Or you could have said this equals 1 minus 2 sine squared b, and you would have been fine. So you could use any one of those three you want. You don't have to do all three. How many are thumbs up on that one? Can't see everybody's thumbs yet. I'm not going on until I see thumbs. Okay. Going on to the next problem down there at the bottom. I think somebody picked the last one. Now, what's this one? What's this one like? Which kind is that from? Half angle. How do we know? It's got a 2 in the denominator. Y'all see it's got a 2 in the bottom? So what this tells me is this top part is the u from the formula. So if you look, we got 2 different tangent u's over 2. I'm going to go back and show you. We got this one and this one. Which one do I like the best? The top one. Now you can do either one. I'm not going to write all both of them down like I did on the last problem. You can use either one, but I'm going to use this top one. So, and again, I'm going to use it because it's later on when we simplify them, it's going to be easier with one thing in the denominator. So we're going to get, oops, got to go back to the bottom here. But this thing equals 1, come on, machine, 1 minus cosine all over sine. What are we putting in there where the u's were? 210 degrees. So all we're doing on those problems is expanding the problem, and that's, so we're done. Now, the next part, we're going to do more than this. We're going to do this same thing on the next part, but we are also going to, oh, no, we're not either. We're doing backwards of what we did up there. We want one function, one angle in our answer. So we're going backwards. So now we want to find out of these problems on the right side, which one do they match up with on the formulas? So you guys pick 19 and 27. Now the second I see a square root on one of these, which set of formulas should I think of?
Half angle.
I should think half angle. And the next thing I look at is there's a plus sign right here. Because there's only one little difference between the half angle for sine and cosine, and we're going to go back and look at it. The little difference is one of them has a minus sign here, and the other one has a plus sign here. So which one am I using? There was a plus sign. You remember I said I look at the plus sign? So we're using cosine. We all see it? So do you see that this is my angle, and I got to stick that on top of the u? I mean, on top of the 2. The u goes on top of the 2. I'm going to go over here too and look at what my u is. So my u is this 20. So that means this is the cosine of 20 divided by 2. You see, I took my u and I stuck it on top of the 2, just like it was in the formula. And then I want to divide this. So what's 20 divided by 2? So this is the cosine of 10 degrees. And you can, if you want to check it, you can plug it into your formula or into your calculators and check it. I'm going to do this one. Now this one might be a little harder to do, but if you remember, I told you that the one I like the best to use looked like this. Anybody remember what that was? That was the half angle for tangent that I just did a minute ago. So what's my u value from this? Okay, let's off this u, sorry. What's my u value from over here to here?
45.
So this is my u, 45, or that 45. So this is going to be the tangent of 45 over 2. Now what's 45 divided by 2? 22.5. And I want to tell you another thing. If you ever see an angle given to you, like they give you at the angle tangent 22.5, if they ever give you a 0.5 or a half, that's going to be a half angle identity. So if you see a 0.5 given to you or a half given to you for the angle, that has to be the half angle identity. Okay? All right, we're going to go on to the next side. The next side is 2. Now this one is harder because it says we're dealing with 2 triangles up here. So if you look up here, we got now this is for these first 6 problems right here. You see how we got A's and B's here? I don't think we got any down here, but let's look real quick. Yeah, they gave us the numbers down here. All right, so first thing you want to do, and it's going to be on the test too, all this stuff's on the test. You see that we have a sine of an angle A, it's saying is in quadrant 2. Angle A is in quadrant 2. So what I do is I come down here and I draw a triangle in quadrant 2. And I put an A here so I know that's triangle A. This one over here is saying B is in quadrant 4. So I'm going to come down here. I'm going to stick a B here because that's the second. And I'm going to draw a triangle in quadrant 4. You have to do this because it told me what quadrants those are in. Now it says sine A is 4/5. SOHCAHTOA. Which one out of SOHCAHTOA is sine? So, right? So that means 4 is the opposite and 5 is the hypotenuse on triangle A. So I'm going to come over here to A. I'm going to go to the opposite and put a 4, and I'm going to go up here and put a 5 for the hypotenuse. Then I'm going to find this x. Because chances are I'm going to have that x. So that means x squared plus 4 squared must equal 5 squared. Where did that come from? That's the Pythagorean theorem that you've been doing for 2 years. Well, actually longer. Because you guys have it a long time ago. So we solved this thing. We get x can be a positive 3 or negative 3. In this quadrant, in that quadrant, what's x? Negative 3. So this is a negative 3 here. Then I'm going to do the same thing down here. I'm going to look at my given information up here. This one says cosine. Cosine's what out of SOHCAHTOA? Adjacent over hypotenuse. So the adjacent is this thing. The hypotenuse is this thing. Now I got to find y. Yes?
Why is that 3 plus or minus?
Because when you square root a number, you have to put a plus or minus in front. And then you look at what quadrant you're in. See, if I would have had a triangle over here, if I'd had a triangle over here on the right side, I'd have used a positive 3 on the right side. Because going from the origin left is negative. Going from the origin right is positive. Okay? All right, so now I'm going to have 8 squared plus y squared equals 17 squared. So 64 plus y squared equals 289. So I'm going to subtract 64 from both sides. I get y squared equals 225. And I'm going to square root 225, and we get y equals a positive negative 15. So y can be a positive 15 or negative 15. So I go up here and I look at this problem. What is the y value in the fourth quadrant? So I must make that negative 15. Now these take a while to do. But now I'm going to use those two triangles on every one of these problems. You ready? Well, actually, you guys pick which problem because I erased it. You pick 2 or 1? Huh? You pick 10. All right, let's do one of these. Which one you want out of 1 through 6?
7.
Out of 1 through 6, you want 7.
No,
Out of 1 through 6, which do you want?
3.
3. I heard 3. All right, so which formula am I using? Double angle for tangent. So here's the double angle for tangent. So this is going to equal 2 tangent A over 1 minus tangent squared A. Right, yeah.
Why's the A not 2A?
Okay, because in the formula, it says whatever this 2u is here only becomes the u part there. Okay? All right, so now I got to go over to which one of these two triangles do I need to use for this problem? The top one. How do I know it's the top one? Because it's got A. So you see why I put the A there? And I put the B here. So on these ones that have the B's, these bottom 3, you got to use this triangle. All right, now what is tangent A? Again, the angle A is this angle right here, and the angle B is that angle right there. So can anybody tell me from looking at this triangle what tangent of A is as a fraction with numbers? SOHCAHTOA, what is it? 2 times what? Can't hear you. TOA, what's TOA? The OA, what is it? Opposite. What number's opposite A? 4. What's the A part? What's the adjacent side part of this triangle for A? So we're going to put right here 4 over negative 3, and right here 4 over negative 3. So you find your thing that we've been doing since geometry, SOHCAHTOA. And now we have to simplify this thing. Because, oh, again, do you see this wording? I don't know if I told this class this yesterday. You see it says exact answer? If you use your calculator and do the tangent of an angle, it's gonna give you a decimal answer. Those are all rounded. You cannot use your calculator to find your answer. Now, you can use your calculator to check your answer, but you can't use your calculator to find the answer. So I have to simplify this. So this becomes negative 8/3 on the top, because I'm taking 2/1 times that. On the bottom, I'm gonna have 1 minus, and then I square this number, and I get 4/9. You square the 4 and you square the -3, and I get 1 minus 4/9. I'm going to come over here and rewrite this. What kind of problem is this? What's this fraction called? What kind of fraction is that called?
Why would 4 squared be 3?
Oh, it'd be 16/9. Thank you. 4 times 4 is 16. Thanks, Gannon. Thank you. All right. So what kind of fraction is this called? It's complex again. Do you remember how I just did the complex fraction before? I look at all the denominators. I got a 3, a 1, and a 9. What's the least common denominator between 3, 1, and 9? 9. So I'm going to multiply this top part by 9. I'm going to multiply this bottom part by 9. So when I take the 9 and the 3, this 3 and 9 reduce this to a 3. So what's on top? Can't hear you. Negative 8 times 3. Anybody know their multiplication tables? Negative 24. On the bottom, I just take the 9 times the 1, which is 9, minus, and I take, because I'm doing distributive property here, and when I take the 9 times the 16, those reduce, so I got this. Then on the bottom part, I need to simplify. That would be negative 7. So what is this final answer going to be? What's a negative over a negative? And can you reduce 24 and 7? Nope, so there's our answer. So those take a little while to do, and they're a little challenging. Yes, sir. Okay. If you were watching a couple minutes ago, well, I think I erased it. Maybe it was over here. We had a complex fraction. And I don't have it up there anymore. I erased it to do a different problem. But we had a complex fraction. That means there's more than one fraction bar. This one has 3. So I always make all of these into fractions, and out of 3, 9, and 1, you got 1, 9, and 3. What's the LCD? What's the least common denominator of 3, 9, and 1? 9. So I multiply the top by 9 and the bottom by 9 to get rid of the complex fraction. Okay? All right, we're doing one more problem, then we're done. You see how this has a 0.5? Now, she already, or whoever made this worksheet already did the favor for you. I'm going to show you what you'll have to do, because I don't think they're all going to be this way. You want to change that 67.5 into a fraction 67.5. And then you're going to change it to an improper fraction. So you're going to take 67 times 2, which is 134, plus 1, which is 135 over 2. And you have to get it to look like 135 over 2, because in your formula, the formula says u over 2. Okay? Am I going too fast? So that means, and they already did this for you. Whoever wrote this problem did it for you, but on the test, they only give you that thing. And you're going to have to be able to change 67.5 to 135 over 2. What's my u value? 135, that's right, 135. Now we got sine half angle. So if you look, first of all, what quadrant is 67.5 in? First quadrant. Sine is which value, x or y? What's the y value in the first quadrant? Positive. That means you only use the positive in front of the radical. You need me to go back? Should I write down? All right, I'm going to write down the formula here. This is the formula I'm using from your formulas And it is the sine of u over 2 is going to equal a positive negative square root of 1 minus cosine u all over 2. That's the formula. And I use the positive one here because sine is positive in the first quadrant. You understand where that comes from? If it would have been, if this would have been like 315 degrees in the fourth quadrant, I would have had to use the negative part in front. If the y is below the x-axis, it's a negative in front. So then I'm going to get 1 minus the cosine of 135 degrees all over 2. Okay, so now I got to get the value of the cosine of 135 degrees. So, I guess I'm going to do the unit circle here. So on the unit circle, 135 degrees is right there. And the ordered pair for in the second quadrant for 135 degrees are these. So which one is cosine, the x or the y? What? Cosine is x. So this is going to equal the square root of 1 minus negative radical 2 over 2 all over 2. What's minus a negative give me? Yeah, these go plus a positive, right? So I'm going to change those signs right now. And now I have to simplify this mess. What kind of fraction is that again? That is a complex fraction. What's the LCD between 1, 1, and 2? 2. So I'm going to multiply the top by 2 and the bottom by 2. So when I do that, I'm going to distribute this 2 first over here to this 1. So when I take that 2 over there times that 1, I get 2. When I take the 2 times the radical 2 over 2, these reduce out, and I'm going to get plus radical 2. And then on the bottom, I got 2 times 2, which is 4. And for the same reason we did that 1 earlier, the square root of 4 is 2, and that's my answer. Does anybody have any questions? Okay, so some of these are pretty complex problems. This is supposed to be done tomorrow. This is number 3 from the sum and difference identity. So I want to show you why pi thirds over pi fourths is equal to pi twelfths. So pi thirds minus pi fourths, what's the common denominator between 3 and 4? 12. So I'm going to multiply this by 4 over 4. I'm going to multiply this by 3 over 3, and I get 4 pi twelfths minus 3 pi twelfths. And I hope you all see that's pi twelfths. That's why this thing right here equals that. All right? Now, I'm going to use the difference, because there's a minus here, of cosine. So if you look back at your formula sheet, cosine goes cos, cosine of the first angle, cosine of the second angle, and then this sign changes from what's in the parentheses. So since that is a minus, this is a plus. It's sine of the first angle, sine of the second angle. Okay, so if you get your unit circle I gave you, it gets radians in there too. Well, pi thirds is the same as 60 degrees. So on the unit circle, at 60 degrees, which is also pi thirds, the ordered pair is 1/2 radical 3 over 2. Pi fourths is 45 degrees. So at 45 degrees, which is also shows you pi fourths, it's radical 2 over 2. The ordered pair is radical 2 over 2. So all I'm going to do now is put these fractions in here where they go. Cosine is which one? X or Y from the ordered pair? X. So do you see right there is a half? So in place of this, I put in 1/2. Cosine is again the X, which down here pi fourths is radical 2 over 2. Got my plus sign. Sine is the Y. So this is radical 3 over 2. And this sign is the Y of this one, which is radical 2 over 2. So I take 1 times radical 2. I hope you all know that's radical 2. 2 times 2 is 4. Radical 3 times radical 2 is radical 6. 2 times 2 is 4. I've already got a common denominator, so I just put both numerators over that common denominator, and that's my answer. Anybody else got any you want to see from that homework?